Welcome to a new tutorial. We will see the use of the foot locking function in a Blender FreeMoCap capture. Here we have a capture of a walking movement. If we see the feet, the foot markers go under the 0 level in some cases. We could adjust the height of all the markers, but there will still be some oscillation present due to capture error. So this is when the foot locking function comes in handy. Here is the function and its different parameters that we are going to explain. We will check this parameters with the help of a diagram. First is which foot to apply the locking. Can be left, right, or both. The next parameter is which markers of the base of the foot are considered. It can be the foot index, the heel, or both. Next is the Z threshold. It is the threshold under which the markers will be considered to be locked. This works together with the ground level. Ground level determines the fixed level of the ground to which the markers will be locked to. The Z threshold must be higher than the ground level. The next parameter is the minimum size of the frame window to consider. This means that it is a group of consecutive frames, whose marker position is below the Z threshold. In this case, you can see that here are 5 frames where the marker of the foot index is below the Z threshold. After the 5th frame, the marker comes out in frame 6, which is above the threshold. Therefore, those frames are not considered for the locking. This is because the minimum window size is 7. But independent of that, the function checks that all the marker are at or above ground level. In this case, the marker in frame 4 is below the ground level, so its position is set equal to the ground level. In the diagram, you can see these are the markers that change after applying the foot locking, and this marker was moved to the ground level. The algorithm continues to analyze the frames, and then here we have 7 continuous frames in which the marker is below the Z threshold. So the lock condition is already fulfilled. But as the next 2 frames are still below the threshold, then these are also considered in the window. Then all these from frame 7 to 15 are the frames that are considered in the locking logic. We move on to another parameter that is part of the locking logic, which is the initial attenuation frame count. This is the number of frames which will be placed following a quadratic function at the beginning of the locking logic. You can see here is the final result. The marker Z position decreases following a quadratic function starting from the Z threshold. This is to avoid the marker be abruptly sent to the ground level. So it is done in a smoother way with the quadratic function. This number here represents how many frames are part of that quadratic function. It is the same as the drawing here, that are 4. The first frame is put at the Z threshold, then the rest follow the curve of a quadratic function until the last frame of the count reaches the ground level. Then there is the final attenuation count that is the same as the previous, only that at the end of the window. In this case, there are also 4 here in the diagram, so that would correspond to a 4 value. All the frames that are in the middle of these 2 attenuation counts have the marker Z position set to ground level. Next, we have this option to block also the coordinates X and Y of the marker at ground level. This should only be used in sections of the capture where there are no feet movement, like when standing still. This is because it can produce an effect of lead or sticky feet. After the whole frame range is analyzed, the new Z position of the ankle marker is calculated. This will change the Z position of the ankle to keep the foot and heel bone's length as close to the median value as possible. We have the knee-hip compensation coefficient. This value goes between 0 and 1 and determines how much of the ankle translation is applied to the knee and hip markers. When the value is 1, all the Z translation of the ankle will be applied to the knee and hip. If the value is 0, no movement will be applied to the knee and hip markers. When using a value lower than 1, it is recommended to have a rig with IK bone constraints in the legs. This way, part or all the ankle translation will be transferred to the bending of the knee. Here you can see the rig has IK constraints. And the last option is compensate the upper body markers as well. The new hip's center marker position is calculated as the average of the left and right hip's Z coordinate. Then the rest of the upper body is translated by the same delta. Let's try different options to see the results. This function only considers the start and the end of the scene. In this case, I set the start and end to the frames 350 and 530. Let's set a specific frame that has foot markers below the 0 level to better check the results. We execute the function, and wait until it's finished. Once finished, we can see that the markers of the feet were moved up to the ground level. Also, the rest of the markers were translated the same distance. We can check this also from a lateral view. Now set the knee-hip compensation coefficient to 0 so those markers won't be moved. This will make the rig's knee to bend to compensate the new ankle height. After the function ends, we check how the knees bent due to the IK bone constraints. Now let's uncheck the upper body compensation and set the knee-hip compensation coefficient back to 1. With these options, only the legs move up or down. We can see the legs moved and the hips formed an angle with the hip center marker. Let's set all the parameters to the default values and execute the function. We check the whole range and see how the feet are locked to the ground level without affecting the movement. This function can also be used to lock the feet to objects at different levels. For example, in this capture we have some frames where the character steps onto a concrete block. We first get the approximate height at which the character's feet step onto the block. We can use an additional mesh as the height of the markers are relative heights, not global. Once we have the height, we set the new ground level, the Z threshold. We will do the left foot as both feet don't move equally. We set the frame range of the movement and execute the function. Now the left foot markers don't cross the level of the block when stepping over it. That ends the tutorial. In case you have doubts or comments, head over to the FreeMoCap Discord server.